Hi, welcome back to the breadboard. In this video we're going to be looking at the Kaiweets clamp meter. This was kindly sent to me for review, and so I want to take you through it, have a look what it is. This is an economical clamp meter. It is designed more for the electricians amongst us rather than electronics engineers, so probably not good for automotive, but definitely good for the hobby home electrician that will be maintaining their own house or doing some smaller jobs. Not really suitable, I don't think, and we'll see as we go through, for industrial use. But here it is anyway. It's only $21 in US dollars, so it is not exactly an expensive meter. So it comes wrapped in a box. I've already taken it out of the shipping containers. We get a user guide. We'll have a quick look at that in a moment. We get some test leads and we get the meter. There is no pouch for the meter or anything like that. Now, I've already recorded this video once, so the audio is absolute crap, so I am redoing it with this one. That's why the battery is already inside this meter. We will have a look inside the entire meter. I'll take the back off anyway. And the meter comes with a pair of probe leads. There is no temperature measurement. Look at the user guide first, but we'll still zoom in. Alright, so the user guide says it's a true RMS digital clamp meter, which is good. It always pays to have true RMS capabilities in a meter if you're going to get one, because you'll get more accurate readings of your AC voltages and things. YouTube video instruction barcodes. So safety information, product overview, safety explanation, etc., etc. Automatic shutdown, auto ranging, inserting and replacing batteries, AC current, AC DC voltage, resistance measurement, continuity, diode, capacitance. Those are the only ranges it has. So it does not have a DC current range. Let's bring that over there a second. So we'll go through each of these capabilities and have a little look at it. Accuracy, page 16 is being specified, and it comes with looks like a 3-year warranty. The usual warnings about usage. Let's have a look what else we got here. Do not hold the meter anywhere beyond the tactile barrier. What that really means is don't go up here, and if you've got high voltages on it, don't connect it to anything down here. Don't keep your fingers near here either. All right, it's meant to be held in the hand like that, so you can operate the clamps, etc. These are all pretty common to most meters. Product overview, current sensing clamp. Let's zoom back out a little bit actually, so we can have a look at this together. So we have current sensing clamp. This is this piece right here. This is a clamp meter, obviously, and your wire goes through there. We have the trigger, which is obviously right here. Rotary function switch for selecting the mode of measurement. We won't be testing anything up in the 200 amp or 20 amp range today, because I don't have any loads that I can put on it AC wise that would test that. We have the function buttons. The function allows you on the second range here to select between ohms, continuity, and diode mode. LED display screen. It's actually an LCD display, not an LED. So that's common terminal for your negative side of the measurements, and your positive input terminal. Okay. You also have a light that can be used, and a max hold button. So that's the safety explanations for alternating current. So these are just explaining symbols. This meter does not have a DC current measurement capability, so the DC current part won't be relevant. Max button. Press the max button to display the maximum value. Press and hold the button for more than 2 seconds to exit the max mode. The H with a star on it is a hold functionality. So it holds the currently displayed value on the display so that it can be read or logged in peace, i.e. when you've disconnected from whatever you're measuring. If you press the button You can also turn on a backlight, so if you press it, I guess, longer. Function we've already talked about. Operating instructions, I'm not going to go through all of these. Just going to have a look, see if there's anything particularly of interest. So if it's not there's no operation of the meter within 15 minutes, it will automatically shut down, preserving your battery life. It's auto ranging, talking about doing AC current measurements and things like that. AC DC voltages, we'll test those out. We'll do some comparisons. Resistance measurements, continuity testing, we will test that out. Diode testing. So again, it only outputs 2 volts for diode testing. There's only a couple of AAA batteries in here, so it doesn't have much in the line of capability for testing LEDs and things like that. Measure capacitance. Just across the probes, there's probably going to be a little bit of an offset on there, just because that's the nature of multimeters. All multimeters suffer from that. And specifications, so 20,000 count, 10 megohm input impedance, which is typical for most multimeters these days. 2 AAA batteries for supply, weighs 240 grams. Cat 3 600 volt is the standard for this. Cat 3 600 volts. We're going to talk about cat ratings in a separate video in the future. I think a lot of people don't understand really what cat measurements are. Accuracy, DC volts should be within 0.5% plus or minus 5 counts. AC volts within 1% plus or minus 5 counts. AC amps 2.5% plus or minus 8 counts. Resistance 1% and capacitance within about 4%. Now, there's an art to measuring capacitors, and so as we go through this testing, you will see that my meter may measure different capacitance readings to the Kaiweets clamp meter, but that doesn't mean that it's necessarily wrong. It may just mean that my capacitance meter is using a different frequency for measuring the capacitance. Maintenance, obviously 3-year warranty, blah blah blah. Okay, that's the manual. Right, so here is the clamp meter. Let's have a quick look inside before we power it up and do anything with it. I did already put the batteries in here, but we're going to, as I said, I did this video once before, hence the hole where the label is for the taking the back off. So, one screw, do it a bit further. The back just pops off. It's separate. The screw comes separate. It's not retained, which would be nice, but so just be careful. Nice thing is that the screw is screwing into a brass insert, which is machine threaded, which is really nice for something that you may take off and on a, I guess, a not frequent basis, but certainly a lot more than taking the back off. The back is held in by 2 self-tapping screws into plastic. Not ideal, but for the price you really can't complain. So let's just take those out. Now the back should come off. I don't even have to remove the batteries for this. 2 little metal tabs that make contact with springs on the board. We have our input terminals at the end here. This is the positive, this is the negative. There are no fuses in here, but that's because it does not do any current ranges using the probes. We have a voltage divider here. It's auto ranging. The controller is on the other side of the board. You can see there's a few basic components, some transistors, probably for switching and things. There may be FETs, a few other capacitors. No real bodge that I can see of. Looks like there's a little DC to DC converter. There's an inductor here. Probably for that. We've got a beeper up here. The current sensing module, which would be up in here somewhere, coming down to the board. There's going to be a coil wrapped around here. And then we have our magnetic coupling cap, a couple of caps, and that's pretty much all she wrote. I'm not going to take this apart any further because it's really not necessary. If you got a fault with this, you'd probably throw it away for $20 and just get another one. So that's what's inside. Pretty simple, pretty basic. But as I said, it's only $20. So no real complaints there. when it's screwed together, it is actually pretty solid. I don't feel any twisting in the case or anything like that. It is a fairly hard plastic case, but again, that's okay. Definitely not waterproof. Not that you should be using meters in a damp environment anyway, certainly not with high voltages around. First range, we're going to start from the capacitance and we'll work our way back up to the current. So here we go, 0 nanofarads right now, and there are no other ranges, it is only capacitance. I'm just going to use my own probes right now because I've got a couple of crocodile clips on the end of it. Okay, so I've got a selection of capacitors here. I also have an Lcr meter here, so that's running at 100 kilohertz right now. I can just plug the capacitors into this connection, so I'll use this connection for Kaiweets meter. So let's just stick on a random capacitor, and we're getting 82 nanofarads. And if I look at this cover, it says 8.2 nanofarads, and this is 8200 picofarads, which means we're pretty much right on there. Let's see what my Lcr meter reads. So as you can see, the Lcr meter is reading 81.4, so they're pretty close to each other, which is nice. Let's just try a completely different value. So we'll do Lcr first. There we go. So we're reading just over 42 nanofarads. So let's see what the Kaiweets thinks it is. We're just testing for basic accuracy. I mean, this is, as I said, more of an electrician's tool. So there you go, 42.6 nanofarads. It's 47 according to the label, so that's not too bad at all for accuracy. What you'd use a meter like this for is for testing, say, a ballast capacitor or a starting capacitor for a motor or something like that. So I'm not going to, I will connect a rather large capacitor just to see what happens, but I won't be surprised if it's inaccurate for doing that. Here's another one. This one is probably about 1 microfarad. Yep, it says 1 microfarad, so we're going up in range here. This is kind of the range that a starter cap might be for a motor. And that's pretty good, 987. And I have a completely random one, don't know what value it is. Didn't check, just grabbed it. So 11 nanofarads. These are all within the range of protection. Actually, I've got a protection diode there for a class Y or class X cap. So 0.4 picofarads. Ooh, 11 nanofarads. Just check that again. So the Kaiweets is reading 11 nanofarads. Okay, so I'm getting 11 nanofarads here. And 11 nanofarads here, so that's pretty good. Let's just quickly try a large cap. This is actually 10,000 microfarads. I don't know if this thing will go that high. Nope, a bit too big for it. Never mind. So that's capacitance. Looks like it's reasonably accurate. Let's flip to resistance now. Okay, for resistance, I'm just going to use the leads that came with the meter. I'm going to compare it to my Agilent U1272A. Now, there is no real comparison between these two meters. This is $450-ish meter, whereas this one is a $20 meter. So you're going to expect this one to be far, far more accurate technically than this one should be. But we're just using it as a reference so that we can see how accurate this one is. We're not worried about whether it's 0.01% or anything like that, because you're not going to get it. So what I have here is a resistance box that Vishay kindly made me several years ago, and it's got 1, 10, 100, 1K, 10K, 100K, and 1 megohm. Very, very precise resistors inside and very, very stable. One of the folks at Vishay kindly made this for me personally and sent it to me, and he hand selected all the resistors and measured them, and there's actually a sticker on the back of this with all of the readings of each of the resistors. So I know that they're accurate, and I know that we're going to have a good comparison. Now these are wired up so that you can do 4 terminal measurements. These first 2 would be one side of all of the resistors, and because you're individually measuring this side can be common to all of the resistors. These are individual so that you can walk your way along. So I've connected one end to the common up here, and I'm just going to go down. This is 1 ohm, as I said, going up. So let's start with 1 ohm and see what we get. So this is moved down and is reading 1.6 ohms, 1.5 ohms. But if I go on here, you'll see that I have a 0.9, 0.8, 0.7-ish, 0.5 ohms offset, which I can't null out. This doesn't have a null function. So if I take off a half an ohm from this side, then it's reading 1.1. Now I'm right on the bottom of the resistance range for this meter. So just to show you okay, if I just short out my Agilent meter for a moment just to get a null reading, I've got 0.11 ohms. So if I can actually null that out on this meter. Okay, so it should be much closer to 0 now. So if I measure 2 wire to this one, I get 1.005. So that's within the range of what it was measuring. So let's go up to 10 ohms. Let's see what the Kaiweets reads. So we got 10.7, and if I zero it again, so we've got a 0.5 offset, and I'm measuring 10.8. So it's really saying 10.3. So it's within the specifications of the meter, because it's if you remember, the accuracy of resistance, let me just pull it up in the sheet again, is 1% plus or minus 3 counts. So 1% would be 10.1, and the 3 counts would make it 10.3, 10.4. And we have the offset, of course, as well, that's in there, which was the 0.4. 0.5. So yeah, we're within spec for that. Next one, this just for comparison's sake, that'll be the 10 ohms. You can see it's pretty spot on. The meter is actually what is slightly inaccurate. So let's go to 100 ohms. Now any offsets is now going to be becoming more irrelevant. So that's within 1%, just plus or minus the count, so it is within specifications. And the Agilent for the 100 ohms, 9999. So let's go to 1K. So again, being an electrician's type of tool, you would use this for testing coils and continuity and some ballast resistors and things like that. So this is still being well within tolerance, 1.000 for the 1K, and the Agilent 9999, so well within accuracy. Let's go to the 10K, 998, so well within its specifications. 10K here, 99998. Let's just check the 100K while we're at it, 9994, and the 1 meg, pretty much spot on. So now let's try this one for the 100K. Let's just do 10K, 998, 100K, 99.9, and the 1 meg ohm, 999. So the resistance is pretty accurate on here. Let's go to continuity test for a moment. Just press the function button, and we're now in continuity testing. So one of the tests for continuity testing is to basically put the probes together and listen. So we've got a visual indicator there coming on, but it's how quickly they respond as well. So it's not always picking up. It's a little bit of lag there. It's not too bad. It's missing the occasional one as I do it. If I switch this one to continuity right here, just doing it with these. It's doing pretty darn good. Visual indication on, obviously on that one has the display. This one has the LED. So that's reasonable. You wouldn't find an electrician type of application running very rapidly through testing anyway. You would put the probes on, wait, listen for it, move to the next one. You wouldn't just be, you know, in electronics, you might be sliding down the pins of an IC or something looking for one. You wouldn't want it to respond quicker. This is not the same application. All right, the next one on there is Diode Check on here. So we'll press function again for Diode Check. Now what we're going to try here is to see if, get my cables untangled slightly, if it can test some LEDs. So I have a white one, a red one, and a yellow one. Now remember, it's only 2 volts, so I'm guessing it won't respond with the white one. So the yellow one, you can actually see it lighting just, and it's reading 1.8 volts, which would be about right. This, I get the same 1.8 volts. I'm passing a higher voltage through it, so it lights brighter. It's putting more current through. But I'm getting the same voltage reading, so that's good. Let's try a red one, probably going to be a similar voltage. 1.72, a little bit lower. And again, it is lighting it. I can hold my probes together. Alright, so that's testing that. 1.76, so read slightly higher on this one, but I'm probably putting a bit more current through it as well. It's certainly much brighter, you can see. With this one, it's still illuminating, but less current. So it's probably at that threshold for the voltage. The white one here is probably not going to light with the Kaiweets, because it requires a higher, more than 2 volts. So I don't see anything in it staying in overload. On the Agilent, because it's got 4 batteries in it, it probably will light it, which it does, and there it is, 2.6 volts. So yeah, there's, you know, for regular checking of diodes, so in an electrician's kind of environment, you wouldn't really come across too many LEDs. What you will come across is obviously filament bulbs and things like that a lot more, but you'd be more checking diodes for rectifiers for motor control and things like that, or protection diodes across solenoids and things. And because they're normally silicon diodes, and they would have a forward drop of sort of between 0.6 and 1.4, 1.5 volts. So this would test it no problem at all. Alright, so what's next is volts. Okay, so let's switch to the voltage range. And I'll switch this to voltage range as well. So now what I'm going to use is this nice device that was sent to me from a friend of mine, Ian Scott Johnson. He has a YouTube channel on YouTube, obviously, and this is his URL. I'll put it in the comments as well. This is a highly accurate DC voltage source. Anything from millivolts right up to 10 volts. It can be supplied from this, and as I said, very accurately. So what I'm going to do is I'll plug in my Agilent directly and then I'll just probe. There we go. So we're starting off, we've got 50 millivolts on here, and you can see I've got 50.0 millivolts here, and I got 50 millivolts here. So now if I put in, say, go up to 100 millivolts, 0.1, we have 100 millivolts, we're reading 100 exactly here and 100 up here. Let's go up to 250 millivolts. So 250 exactly, 2499, pretty accurate. Let's go up to half a volt. Oops, 0.5, enter. So again, very accurate. Let's go up to a full volt. So well within its accuracy. The accuracy for the voltage range on the Kaiweets HT200B is, go back again, DC volts is 0.5% plus or minus 5 counts. So that's only 2 counts out, which is well within specification. Let's go up to 5 volts. So 5.01, that's well within spec. They're all correlating. And we'll go up to 10 volts. So there's 10 volts, all working well. Again, well within specification. So the question now is, what can we measure from an AC perspective? So this is a little trickier. I'm going to plug into a mains supply carefully, and we'll do some AC voltage measurements. See if they, I'm just going to test it at 110 volts, and we'll just see if they correlate. Okay, so for AC, I'm going to just test with the mains, just to do a spot check, because typically that's what an electrician will be doing. So I'm just connecting into here. Don't copy this. And I'm also using some very safe tip probes here, which are very, very short, so they can't slide over and short each other out. So I'm just going to connect them onto here, and then I'll have this one reading from the same source. So there we have it. It's 123.6, and I have 123.78 on the other one. So that shows me that these are reading pretty accurately, which is nice to see. Now, the other thing you'll see on the Kaiweets when I connect it is it's actually lighting a red, orangey red display here to warn you that there's a dangerous volts that you're playing with here. So you need to be careful. So let's just unplug this now. So that's the AC spot check up the high voltages there. Now the next thing I'm going to do is measure some current. So for that I'm going to change my reference meter to a different one. Okay, so I've got both meters set up in series with one leg of the mains. So they're going to measure the same current. I got them in the same leg. Doesn't matter which leg you put them in, as long as they're only in one leg. I'll show you that in a moment after we've done the current check. So they're both reading 0. I had to make sure this one is set for AC current, not DC current. This will do both, this particular meter. So let's turn this on and see what we get. Okay, so we're reading 751 milliamps over here. We've got it on the 2 amp range. And we've got 7.2, which is just rounding down a little bit. Do I have any 0? Okay, so 7.2, 7.4, still pretty accurate within its range. This one is designed to go to a much, much higher range, so it's got less digits to play with. So it's just working at the bottom of its range. This one is a professional electrician's kind of tool, but it does DC current as well. So it's a completely different class of meter, clamp meter. So I can't put any more current on here, but what I can show you is that if I take this meter and I put it on the other leg, you'll see that it makes no difference, right? 730, 739, 740. So what I can do with this one is go up a range. So now that's reading 680, but it's only 2 digits of accuracy. And then I go to 200 amp range. Now this is reading 0.6. So it's 0.1 of an amp on the maximum range. My meter here was already on its lowest range anyway. So it really doesn't make any difference there. All right, so I'm going to take this away a second, this one, for my reference, so we can see it's measuring current quite happily and quite accurately, or reasonably accurately. So if you had a meter that was, say, only had a 200 amp range and you wanted to get a better idea of what the current was, remember this is only 750-ish milliamps, and now we're within tolerance, but we're not getting the kind of reading we want. One of the things that you can actually do is actually wrap the cable around the clamp meter more than once. So right now this, even though it's not looped, it's going through it just once, which counts as one turn. If I actually wrap this a second time, you'll see that my reading has immediately jumped up. So if I go back to the 2 amp range, you'll see now it reads 1.499, so 1.5 amps. Oops, stay there. If I take that back out, right, now we're back to about 735, 740 milliamps. So if I do it a third time, it will be 3 times. Now it's overloading because it's thinking it's over 2 amps. So now we've got 2.16. Now if you know how many turns you've done, you can divide it by the number. So here it's 3. Once through, twice through, 3 times through. Divide that by 3, gets you back to the range. But you can take advantage in some cases where you have a low current that you want to measure, and you need to bump it up to something that is actually more accurate on the meter. And one way of doing that, like I'm showing you, is looping it multiple times. So if I did 10 turns on there, it would turn the 2 amp range into a 200 milliamp range. If I did it on the 20 amp, it would become the 2 amp. Okay. Unfortunately, you can't do the opposite where you multiply, but we're multiplying what we're measuring. We have to divide it back down again. You can't do the opposite because you can't go less than 1 turn. Anyway, that's one way of increasing the sensitivity of your meter if you don't have the lower ranges. This one's pretty good with a 2 amp range, so I'm quite happy with that. So just to show you a couple of other things, it doesn't matter if you try and measure this way, it's not going to work. See right there, it's reading 0 because the magnetic field flowing in one direction is being completely nulled out by the current flowing in the opposite direction, which is equal and opposite. So you don't get any reading. I mean, this is just an offset. So remember that you can't just clamp it over a cable like the standard mains cable and expect it to work. It's not going to work. You have to be just over 1 core. Okay, it doesn't matter if it's live or neutral. It's about current here, not about voltage. So that's the Kaiweets HT200B meter and its probes. So what are my thoughts now that we've gone through it and had a little play with it? I definitely wouldn't want to use this in an industrial environment, right, where your energy, if you're trying to measure mains with 200 amps or something higher, like a 3-phase circuit of 415 volts or something, I really wouldn't be taking this into that environment. This is great for hobby home use, but not really for a professional. If you're a professional doing electrical work, industrial or even commercial, then something like this, or one of the big manufacturers like Fluke or Agilent or something like that, would be more recommended. You probably wouldn't even get this officially in the door of some official establishment and company. But like I said, for home use and hobby use, ideal. Doesn't do DC current though. So no good really for electronics or anything like that. I mean, at a push, you've got a lot of things you can do. You can still measure resistance. You can still measure voltage. You can still measure capacitors. And you can measure AC current. But you can't measure DC current. So limited, but for $20, not a bad little tool to have for a handyman for working around the houses and things like that. The leads, they're functional, but they're a bit stiff. When I actually had these in, I was having an issue with the stiffness of them, where it won't stay still. So it'll be a bit more difficult to position the meter somewhere. There's no balun on the back of this for propping it up. Like this doesn't have one either. So that's not a big loss. most other multimeters do have them, but these are not really, strictly speaking, the same type of device. The ranges are great for what you do have for current measurement. And it does have the high voltage warnings for you, which is nice. And what else is on here? Yeah, comes with the batteries, which is always a nice little thing. So, Kaiweets HT200B, would I buy one for myself? I think as just a hobby tool around the house, I probably would. If I wanted to be an electronics engineer, though, and using this as for dual purposes, then I'd probably look for something else that also included DC current as well on the clamp. But as a general meter, it seems to be okay, and for $20 you really can't complain. So would I keep this in my toolbox? Yes, I would. I would be wary about where I use it, though, that's all. And that's pretty much it. That's the Kaiweets HT200B clamp meter. I'll provide links to this if you're interested in getting one for yourself. And I'll have more videos coming up soon with other devices. Some may be from Kaiweets, some may be from other manufacturers to look at for use within the lab and around the home. Well, if you like the video, give it a thumbs up. If you don't, then don't. And I'll see you soon.